Welcome to the brief presentation for the Safety Suite for Electric Longboards project. My name is Alexander Krysl, and my partners were Pouya, Akbarzadeh, and Patrick Stach. First of all, what is an electric longboard? It's a longboard with electric motors and is controlled via a remote control. Some of the problems with commercially available electric longboards is threefold. First of all, they don't discern whether the user is atop the board or not. Second, because they use skateboard wheels, they are prone to losing traction, and that causes loss of control for the user atop the board, another problem as well. And then thirdly, some electric longboards do not even tell you how fast you're going or how much throttle you're inputting, which the user can lose track of as they're having fun atop the board. So here are the solutions that we applied for a custom electric longboard we made for this project. In this video, you can see that when I'm not on top of the board, the remote tells me that the user is ejected with that bottom line. As soon as I step on, it goes away, and you can hear a chime that associates with that. As soon as I step off, user ejected comes back and forth as I step on both of our pressure pads. And then in this case, when I fully mount the board, it's fully gone and ready to go. So here is to demonstrate how that actually affects the motor control for our custom board. In this video, we'll show you a commercially available electric longboard, the boosted board. If you put full throttle with no user, it will rocket away. It has no discern of whether you're on top or not. And then with our board, when we put full throttle with no one on it, it'll go at a leisurely pace, not too fast, which is much safer in case you accidentally apply throttle when you're not atop it. In the next example, we'll have for our second solution, the loss of traction, the wheel slip issue. I'll actually direct your attention to the bottom half, which shows you what commercial electric longboards will do if you let them. Essentially, this scenario is where you're going at speed and then you pull full throttle, reverse throttle, full braking throttle, and what will happen is that you will effectively lose traction on those rear wheels. As you can see on the bottom, the wheels are slipping out of control, and so long as you hold that throttle back, that is what they're going to do until you stop, which is definitely very dangerous. You definitely don't want to lose control as a result of that. So for our solution on the top half with our traction control enabled, what we attempt to do is just to apply like a pump the brakes, kind of like a ABS system on a car. And we're able to do that because we have the reference point of our front wheel custom encoders that we built for our project that tells us how fast we're actually going. Finally, for our third problem solution, we have limited communication with the user. We added a display into our remote, and this actually can tell us a bunch of things. And what we display here is actually, since we know the RPMs of all four wheels, we can tell you each of those individually. Luckily, for about every 100 RPM for a skateboard wheel on our board translates to about 1 mile per hour, so that's pretty convenient for that conversion. As well as we also demonstrate the amount of throttle you're inputting. The range goes from -128 to 127, and if you look on the right-hand example, in that example we're just applying 4. So that tells you how much you're actually applying, how much the board is seeing. Finally, in conclusion, this project was a grand success. We were able to achieve all the goals we set out initially. We created a product that I actually continue to use to this day. It's a lot of fun, and we certainly learned a lot. It was a genuinely great experience. And thank you so much for watching our brief presentation on our project. Thank you so much.